So there it is. Linear inequalities involving optimization. That's the title of today's lesson. Okay. Optimization problems are related to a system of linear inequalities right? Optimization problems are related to a system of linear inequalities, where we will need to determine the best solution. So far, we narrowed it down to the corner points. But out of them, there will be only one ultimate solution. Note the true region for all inequalities is also referred to as the solution region, and sorry, I'll go comma, right? Comma, solution polygon, or feasible region. And the reason why I'm giving you all of them is because sometimes certain worksheets are kind of taken from a textbook or whatnot, and so they all mean the same thing, right? The true region for all inequalities, which is really the area that has not been shaded, right? That is left over, that one is called solution region, solution polygon, and also the feasible. It's feasible to get a solution out of that region, okay? I will talk about the objective function. An equation that relates the two variables in the system, x and y, whatever that is, comma, which will determine the point that maximizes or minimizes an outcome. And note, the objective function is not an inequality. And now we're going to do a brief example. Consider the graph below. So we're just going to make this up, okay? It's not going to be perfect. And let's say you have a line coming down this way and another line that cuts through it and goes this way, right? And what we're going to do is we're going to shade everything, but we're going to leave this area as our solution region. Okay, so this is our solution here. So when we solve these, right, we come up with our inequalities, we graph them, we come up with the solution region after shading. We have our corner points. In this case, it would be whatever surrounds the solution region, right? And let's say this point right here is 3, 2. This is 0, 3. This is obviously 0, 0 here. And this is 4.50. That's just an example. This could be anything, right? The variables could be X and Y, it could be hours and money, you name it. Okay. Consider the graph below. If the objective function is, this is what it always looks like. It usually has a capital letter and it has coefficients in front of both of the variables in question. Okay. So we will do A here. Determine the combination will maximize output. Determine the combination that will maximize the output. And this is what we're going to do. We plug in all corner points and see which combo results in the greatest number. So we graph, we came up with our objective function, even though I told you what it is, right? So there it is. Now it's asking determine the combination that will maximize the outcome. So you line them up, like this is how I show it. You put it, order doesn't matter. So 0, 0, 0, 3, 3, 2, and 4.50. Now, of course, depending on what we're talking about, continuous or discrete, you're going to have to round your corner points to a whole number. But basically, we take those points, you take your objective function. So here C would be 3 times 0 plus 2 times 0, which we know is just 0. Here, C would be 3 times 0 plus 2 times 3, which is 6. Under the third category here, C is going to be 3 times 3, because x is 3, plus 2 times 2, because y is 2. So this would be 9 plus 4, and that's 13. And C here would be 3 times 4.5 plus 2 times 0. And we know this turns into 0. So this would be 13.5, like that. This will be the maximum here, right? Out of all three combinations, this combination down here results in the maximum output. So we'll say conclude a combination of 4.5 and 0 will maximize output. And this will be different once we do word problems. It'll mean like a combination of 4 socks and 5 pairs of gloves. Producing that will result in the maximum income and so forth. Yeah. Uh, sorry, say that again. It was a little quiet here. For you actually only consider the corner points from the surrounding your solution region. So you know, so far we've done that. We've come this far where we come up with the corner points. And it's only one of the corner points that will actually result, in this case, in the maximum output. So you only consider the corner points when doing this. Does that make sense? Yeah. So here it is, right? You just consider all corner points when you do one of these. So where does this come in? Well, so far you would just graph and come up with the corner points, which are some of the options you have. But what if the question says, how can you maximize your income, or how can you minimize cost? Like if this question right here, I went A, I wanted to maybe go B and say, hey, which one of the corner points will minimize output? Well, it's obviously 0, 0, right? So you got to watch for the wording. And 0, 0 would be a very easy solution here, which probably wouldn't happen on a question, right? I'd be making it in such a way that 0, 0 is not an option. Okay, so that's kind of like the intro to what's going to come next. We're going to add this section here to our questions. We've come this far, stating the corner points, and now we're going to do objective and actually plug them in and find the solution. Okay, so let's do a word problem that will walk us through this whole thing, and probably I think we'll be lucky if we make it to this one. Okay, so here we go. A parking lot has 540 square meters of space available. A car needs 9 square meters, while a bus needs 36 square meters. The parking lot can have no more than 95 vehicles at any given time. The charge is $7.50 per car and $25 per bus. What combination would result in the maximum profit So our parking lot has 540 square meters of space available. A car needs 9 square meters, while a bus needs 36 square meters. So that's, I guess, including all the space that you would need around, because you obviously can't park them back like right next to each other because you couldn't get out of it. The parking lot can have no more than 95 vehicles at any given time, and the charge is $7.50 per car, while you pay $25 per bus. Right? What combination would result in the maximum profit? And here it is. They're not just saying give all possible combination. They're asking you for what combination would result in the maximum profit. Okay? So you need the answer, not just an answer. You need the ultimate answer. So this is what we call optimization kind of questions, which will have an objective function, guaranteed that you will have an objective function coming out of this, which is not an inequality. It's just what we use at the end to come up with the best solution. Okay? So let's go through the steps here, which I've been doing a couple of times. We need to let x and y be something. What would it be in this case? If you read it carefully, you should probably realize, like, what are you talking about combination? Well, combination of cars and buses, right? So we would say number of cars, and y would be number of buses. Somewhere we're going to state this, right? And this is discrete, meaning we can't have decimals for our corner points at the ends. Okay. Secondly, let's come up with any inequalities that are mentioned here. And what I ask you to do is look for restrictions. Okay. What is the first restriction here that limits what the parking lot can do, Anthony?
The parking lot only has 540 square meters of space.
That's right. So there has 540 square meters of space. So that's inequality number one, right? So I'm going to call this inequality number one, okay? Up here is inequality number one, IQ1. So you get your first inequality out of that somehow. And you notice that they do talk about space that each one of them occupies. So you know that with these two here, you're going to somehow come up with an inequality that will satisfy that, okay? And then the next inequality, what's the next one? Somebody other than Anthony, maybe. What's the next inequality that shows up? Yeah. No more than 95 vehicles, that's right. There we go. At any given time. Is there any other inequality? I'm going to go IQ2 here. Any other inequality that you notice? If you at home see one, you can type it. That's okay, or you can say it. And you're like, what about the dollar amounts? Like, what's up with that, right? There's no restriction put on that, is there? There's no like they can only make so much money per day. Nothing like that. So what that means is that this is not, you're not going to need that for any inequality. That dollar amount is there to later on talk about the maximum profit. You will get your objective function out of this one, out of the 715 to 25. So let's come up with our inequalities. So first the 540, so that'd be 9x plus 36y, that has to be less than or equal to 540. Maximum of 540 square meters, right? And then it says that you cannot have no more than 95 vehicles at any time. So that means that the number of cars and the number of buses has to be less than or equal to 95. Maximum of 95 vehicles. Watch for the wording, okay? It's not always going to be less than, right? If it says at least, right, then you need to have something there. Okay? Third, we're going to graph it, right? So let's go 9x 36y less than or equal to 540. We're going to come up with this. So I'm going to kind of race through this step because this one you should be able to do quite well. And we get 9x is equal to 540. Divide both by 9. You can see that, sorry. X is equal to 60. So 60, 0. We'll do the same thing here. That results in 15, so it's 0, 15. I have my intercepts. 36y is less than or equal to negative 9x plus 540, divide everything by 36. Y is equal to, I'm just going to do this because, right, 9 and 36. Oh, yeah. Ooh, that would be huge, right? Because then it's just a line, right? It's not an inequality. So thanks for catching that. Plus 15. If you want to leave this at negative 9 over 36, go for it. There's nothing wrong with it. We're not. Is it Friday?
I don't know.
I don't know. It seems like it's Friday based on my mistakes. That's how it goes. Oh my goodness. Solid. True region is below, so we shade above. And the other one, I think I can do this right underneath because it's going to be a, right? Um, we're just going to go 95, 0, 0, 95. And we don't need to do the whole thing because this is one of the easiest ones that you will get. Plus 95 like that. Solid, shade above. So I kind of, right, separate these two. And now we're going to graph it here. I'm going to graph this up here somewhere. So grab your rulers if you have one. I need to go all the way to 95, right? So I'm going to go probably, oh, one second. Hold on, don't graph it yet, don't graph it yet. Because it's so far away, I was reading 95 cars, supposed to be 45 cars. That 4 looks like a 9. Let me just see, because if we do 95, this graph is, the second line is going to be irrelevant. That's my only worry here. I don't want that to be the case. Can we let's go fix that, okay? It's easier to fix it to 45 than to make this, otherwise it's not going to work. My bad. So all the way to the top here, change that to a 45. It should be fairly easy to do. Okay, everybody at home, change the 95 to 45. And then we're going to trace it to our inequalities. That should be 45. Right? It is, yeah. It probably is Saturday already at this rate. So nothing changes. So make sure you change it in the inequality. Otherwise, you're going to go back in your notes and you're going to wonder what happened. And back here, this is going to be 45, 0, 0, 45. And then change this to 45. Like everything that is 95, change that. Okay. My apologies for that. Okay. So graphing, I'm just going to go 10, 20, 30, 40, 50, 60. That'll do for the x axis. And I'm going to probably do the same going up. So 10, 20, 30, 40, 50, 60. As long as you're consistent, I know these ones aren't, they're spaced a little further apart on the y-axis. You notice that, right? But it's okay because it's a different axis and that will be okay. So number of cars, number of buses. Don't forget that. Do that right away, right? And then label every other so we know what scale you're using. So it's 60, 0 here, 0, 15 up here. Graph that there. And the other one is just 45 and 45. See, if that had been 95, they wouldn't have crossed, and I wanted them to cross. Otherwise, it wouldn't have been a big deal, right? And both of them are shade above, so we stick to this line here. We shade above like this. And this one too. So you kind of follow. I know that you might think, why are we taking one line at a time? Well, I think if you don't do that, you risk shading in a section that you're not supposed to. Okay. I'm going to zoom in again. And then your label solution region. For the sake of time, you're just going to copy down the corner points as I'm telling you, right? So corner points, we're going to go 0, 15, and we're going to go 45, 0. And this one right here is 45. 40 and 5. And don't forget about 0, 0 here. Right? So you have 4 corner points like that. Just write them down. The objective function, why do we need the objective function? To determine the maximum or minimum, depending on what the question says. And they say profit, so we're going to use capital P. And how would you determine the maximum profit? Well, that's where the dollar amounts come in. $7.50 per car plus $25 per bus. And it's not an inequality. This came from basically that last sentence there in our problem. So and make sure all of them are round numbers, so we don't need to worry about rounding. 0, 0, 0, 15, 45, 0, and 45. Those are our corner points. We're going to plug it into P. And calculate. Yeah, let's get this done before the bell goes. Okay, so this one is obviously 0. We're not going to sweat that one, right? 0, 0. This one is 25 times 15 because x is 0, right? It will turn that first expression into 0, so we're not going to worry about that. The second one is 750 times 45, and the rest is 0, so we're going to calculate that. And this one has both x and y are non-zero numbers, right? So 750 times 40 plus 25 times 5. So we already got 0 here, obviously not going to be the max. This is 375. This is 337.50. This is 425. So which one of these results in the maximum output? It's this one. This is the max. Okay, so we state a combination of 40 cars and 5 buses will maximize profits. And just so you know, I could completely change the original numbers, right? And we would come up with a completely different solution, right? If I put some other restrictions in there. But this combo is what's possible based on the restrictions that we came up with. Okay. What I want you to work on, there are, and again, I'm not sure if you have this handout. See if you can find this one right here. Sorry, mine is already highlighted and whatnot. Can you let me know if you have this? Do you have the handouts all? This one, Alyssa owns a small business selling pizzas. You have it? Like this one I thought I did. Okay. This is your homework, and I will post a PDF of it as well. I would say part of your homework should be